Go ahead and get started. So first, starting off, my name is Tommy Moussis. I'm a customer success manager with Graitec, and I'll be presenting this with Sarah Santana, who's an application specialist within the structures team. She's going to be presenting advanced design. So today's webinar is going to be about integrating design solutions with Revit and advanced steel. We'll also be taking a short brief look at Robot as well. Robot is also an analysis solution, a design solution within the Autodesk portfolio. However, we'll be taking a look at advanced design mainly through this integration process. The webinar overview. So once again, we're just going to be covering the workflow between Revit, advanced design, Robot, and advanced steel, the do's and don'ts of working with an analytical model. We're to be focused on the Graitec advanced design product. And we're to be talking about the time saved with synchronization and best modeling practices. The next slide, here we're just talking about the workflow. So the workflow between Revit, advanced design, and advanced steel heavily depends on, of course, the skill set of your team and what type of project you're working on. If it's quite a large project, there might be a few tweaks to the workflow. However, mainly for a design build project, you'd want to start with Revit to build conceptualize your model and to create the general arrangement drawings. And then you'd want to use advanced design to refine your model, maybe update the section sizes within Revit afterwards through synchronization, and then export your model from advanced design to advanced steel as well and bring it to a higher level of detail, add in the connections, extract the assembly drawings, of course, number your model, and then extract the DSTV files if needed for fabrication, and then bring it all back into Revit so that you can have all this information in one model. In advanced design, we're to be taking a look at creating the load areas, creating supports, automatic generation of wind and snow loads, optimizing these combination loads, and also analyzing the structure. We're also going to take a look at the tools to visualize the results, post-processing results, the general optimization tools for the steel sections, using the Graitec BIM designer for steel connections, and outputting the reports from the connection designer. So we'll be showing this slide again afterwards, but we have many webinars upcoming. We already had one today in the morning for advanced steel and Plan 3D collaboration, but we will have many more throughout this week and next week as well. Let's just go ahead and get started. Now, we're to start by taking a look at the Revit model. We have a smaller model here just to be able to showcase the changes that are made and just navigate through everything easily and quickly. So when exporting a model from Revit to advanced design, the first critical thing here, I'm just going to go ahead and turn off certain elements to easily visualize that, and I'm going to actually turn on the analytical nodes. So this analytical model that you're seeing here, all the nodes are touching one another, and this is actually critical for any sort of analysis solution. You want to make sure these nodes are touching and everything is in the correct alignment so that the engineer can apply the combination loads without any issues or errors. Now, these, of course, if ever you have a node that's not touching one another, the engineer can rework that model and fix any of those issues within advanced design. However, it's just important to keep within that mindset that if you're to use Revit with any sort of linear analysis software, you want to make sure the analytical model is correct in the sense that the nodes are touching and so on. Now here, I'm just going to go ahead and turn the objects back on. And another thing to note is that, of course, there's the importance of the alignments. Now, this is something more important for the engineer in terms of using Robot or advanced design. Having the members set to top fiber like this is a common need for a designer. You want to set your members to top fiber or to top of steel to facilitate your elevations, your placement of members. You might want to shift your columns from the centroid to outer inner flanges for the frame, etc. It's just important to note that when you export your model into advanced design, depending on how you want to analyze your structure, you can turn off that you're taking into account the eccentricities of your members for the combination load. So this is just something that Sarah's going to talk about a little bit later on. Now, let's take a look at how we can export this model into advanced design. So here we're going to use under the Graitec Power Pack, the BIM Connect tool. There's many settings that you can adjust, okay? So just be sure to open the settings dialog and make any sort of changes to be able to import, export different objects. Of course, here we want to export and import all the loads. We want to make sure that is checked. And here we'll go ahead and click on export. Now, another thing to mention is that, of course, with the Graitec BIM format, you're to be exporting a GTC-X format, which is the Graitec native file format for BIM Exchange. However, you will have the industry standards available to you as well. You'll have the SDNF, CIS2, IFC, and PSS formats. And here you can select your country, library, and settings. So I'll go ahead and click OK. And now we will be asked if we want to generate a report for this stage or this phase. We don't really need to output a report, and it will automatically launch advanced design and import that model. Now, what I'll do is actually let Sarah take over. So Sarah's going to go through all the features of advanced design and show you how you can refine the model and run your analysis. So Sarah, go ahead.
Good afternoon to everyone. Before continuing with advanced design, I will just show you how to take this model to robot if this is the design solution that you want to use. So actually inside Revit, you can go to Analyze, and then you have this icon, Robot Structural Analysis link. And if you click here, then you will be creating a model like this in Robot where all the elements are connecting and they are well orientated. So you can also work with this design solution. So going back to advanced design, my model looks like this. In advanced design, we can select any element from the graphic area, and on the right side we have all the details regarding the type of element. If we select to work with S-beam or beam or variable beam, we have the material type, also the cross-section. If we want to work with eccentricities, we have the options here for the eccentricity, or we can just disable this for the FEM purposes. We also have the option of creating hunches for every element, changing the orientation of the elements, creating releases, adjusting the mesh parameters, and so on. And of course, we have all the design parameters here, which are very useful and comply with the Eurocode 3 for steel. So it is very easy to change the parameters, characteristics of an element in advanced design. Now, if I want to create, for example, supports, I have the options between point supports, linear supports, and area support. In this case, I will select rigid point support, and I will change the type to pinned. And just by clicking on the base of every column, I create my supports. So you can select these supports in a graphic way and then modify them, or you can go to the pilot, which is on the left side of the screen, and you have all the supports listed. Now I can also create loads with advanced design. As you can see here, I have many families: dead loads, live loads, wind, snow, accidental loads, and so on. If, for example, I want to create some live loads, I have the choice between point, linear area, and also impose displacements. I will choose area load this time, and I will give the vertical value, and then I just have to click on the points needed to create this area load. So at least 3 points. I can display these loads on the graphic area. This one missing. I'm creating it again. Okay. So now we have 2 area loads. They also appear in the pilot. You can modify them from the graphic area as well. And now if you want to create wind and snow loads, you first need to create load areas. So load areas work as non-structural elements. They serve like panels to distribute loads. So I will select load area, and then you have to create these load areas on each face of the building. You can copy them very easily with the advanced design tools. And we have to create an area load for each face because the building needs to be closed. Otherwise, the generator of wind and slow loads doesn't work. Of course, you can also change the span direction of every load area. Here you have the options of setting this span directions. Now that we have created the load areas, we are able to create the wind loads. So there are many ways you can create your wind loads manually, so case by case, but you can also create them with automatic generator of advanced design. This is a very useful tool because it's very cost effective. You create many cases in just a few seconds. So before creating these cases, you have to set the parameters of the wind. According to Eurocode 1, you have the option of setting, for example, wind speed regions. I can select from this map, and also direction coefficients. I can set the altitude and some other factors. And once I'm done with these parameters, I just have to right-click on wind and then automatic generation. As you can see, many loads appear. You have the list of the load cases here. You can take a look and see which areas are loaded. So this works the same way with the snow. You set the parameters and then right-click automatic generation. So if you have created your load areas, they work for both wind and snow loads. Now let's create some combinations. For combinations, we have very user-friendly dialog box. We can use the simplified combination option, which enables us to set the project situation here, predominant actions, and also change the type, the category of, for example, live loads. I can set them to meeting places, storage, housing, residential areas, and so on. And of course, these coefficients depend on what you choose here. So once you're happy with your configuration, you click on generate, yes, and then you will have a list of all the combinations created for the analysis purpose. All right, now let's see how to create connections. In many softwares, you have the option of creating a connection separately from your analytical model. But in advanced design, you can create them directly here and design them with the BIM Designer State Connection model. So to create a connection, it is very easy. You can go through the objects menu. You have different types of connections here. BIM to column fixed connection, you have splice connection, end plates, base plates, or you can just select two elements, right click, connections, create on selection, and then select the connection that you want to create. Okay, and now you can see there is a small symbol here. That means we have a connection. We haven't still calculated this connection because we need the analysis results first, but the connection is already here. We will work with it a bit later. All right, so now you can select among the analysis options. You can launch the FE calculation separately and see how your structure behaves, or also launch the steel design where you can really choose your cross sections adapted to the requirements of the Eurocodes. So if I click on both of these, I will have my results after a few seconds. So you have on one side the FEM results and on the other side the steel design results. For every result, you can save a view. I have here some saved views, and you can go through whenever you want. So I have, for example, displacements for the dead load case. I have vertical forces for the dead load case. I have bending moments, also lateral forces. I can also select one of the other combinations from the list here. And I can display as well my steel design results. So for example, here I have the deflections, the work ratio for lateral forces, vertical forces, and also for bending moment. As you can see, the lateral girds are working beyond their capacity. We have a percentage over 100%. And you can have more details if you click on one of these elements and you go to the detailed results for each element. So you have all the results from the analysis here. I can use the optimization tool to change these elements and have another one complying with the codes. For this, I just have to click on this button and I can see from the list these elements are not good, are not correct in terms of structural behavior. So I can just click on the right column, which are the accepted solutions from the suggested solutions of advanced design, and then click on OK. Now I have to perform again a calculation, so FE calculation and steel design. And after a few seconds, I will have my updated results. So you can see I have the same views as before, and I can take a look at the moment work ratio. I can see now I have a percentage work ratio that is correct. So I can say that my model is working in a proper way. So now let's see how to design the connections. For this, we just need to go to the design mode on the pilot. And you have a list of every created connection. Just have to double click on one of these, and you will be prompted to a different interface where you can visualize all the internal forces coming directly from advanced design and being used for the calculation of the connection. You can also change the parameters of the connections if you want to change the thickness of the plates, if you want to change the diameter of the bolts, and so on. So for example, here I have all the loads and combinations coming from advanced design for the right beam and the left beam. You have all the internal forces here, so you don't have to input them again. And I can change the characteristics of my connection using the geometry icon. So I can change my stiffeners, the plates as well, thickness of the plates, the bolts, the bolt grade, materials, welds, chamfers, and so on. So once I'm happy with the configuration proposed, I can just calculate my connection, and I will have results in a resumed way, or I can also create a report. So now I have the results. For example, here you can see for the flange weld, everything is okay, bending moment, bolt shear and tension, and so on. So I can create a report for every connection, and they will look like this. It's a very detailed report. You have some drawings at the beginning. You have a description of every element, so both rafters. Also, you have some characteristics of bolts and plates. Then you have a detail of the load combinations used for the calculation, design assumptions, and all the verifications according to the Eurocode 3. So you even have the section from the code, the table from the code, so you can check very easily every parameter. All the verifications are presented in this report, and you have the same type of structure for every connection. So for example, here I have a moment end plate report. I can see the drawings, I can see characteristics of my connection, the bolts, the end plates, loads, verifications, and also every reference from the Eurocodes. And same thing, for example, if you create a base plate connection, you even have details about the anchors and other elements. So it's very easy to check every parameter according to the EUR codes. You can also ask Advanced Design to give you a bill of materials, bill of quantities, which is needed to estimate the amount of steel and of every cross-section that you will be needing on site. So once I'm done with the design of this structure, I can take this model back to Revit. So we have everything in one single model. Or you can take it, for example, to Advanced Steel for detailing purposes. So if I want to take it back to Revit, I can go to the BIM menu and then export my model. So AD model to Revit, save, and then I open again my Revit model, Graitec Power Pack, BIM Connect, and now we will use this synchronization. So this tool will enable synchronization with all the changes we made in Advanced Design. So I will select my model. You will see the list of all that has been changed or added. Once you can select all of them, then right-click, accept. We will accept every change, and then we click on apply, and you will see how the loads appear in Revit, meaning that Revit recognizes these loads, and all the cross sections will be updated if they have been modified in Advanced Design. This takes a few seconds. Okay, we're almost done.
Sometimes it takes a little bit more time depending on the size of the model, but on average it's in between 15 seconds to a minute.
Yeah, so today node mapping. All right, so now you can see all the loads appear here. Revit recognized this as wind even, which is great. And then you also you can also, for example, select this one is a live load, and you will see the base plates as well are created, and all the cross sections are updated. So from here you can take this model to Advanced Steel for detailed purposes, or you can take the model directly from Advanced Design to Advanced Steel. So I'll pass on to Tommy so he can talk you a little bit more about these steps.
All right, thank you very much, Sarah. So that was a lot of information, of course, in advanced design and how you can analyze your model and really do it in an efficient way and save a lot of time in that regard. Here, one thing to point out, okay, of course, you might not want to see all these additional elements. These are Revit elements, of course, inside of Revit, these load cases here. If you just wanted to turn them off, all those visual settings can be controlled here. So if we were to just go and turn everything off with the analytical model, you'll see that all those elements will not show. Now, as Sarah mentioned, at this stage in the project, you might want to update your Revit model, or again, you might want to just send your model to Advanced Steel to then take your model to a higher level of detail, add in the connections, any miscellaneous steel, stairs, or railings, as well as number the model and output fabrication drawings. You can output the general arrangement drawings again in Advanced Steel. However, this can be done in Revit, and in order to save time, you might want to split or divide that workload between the departments. So have the general arrangements done in Revit, and then have the fabrication details done in Advanced Steel. Of course, on that workflow, there would be another webinar talking a little bit more about that. So tune into that webinar if you want to see that workflow and how to work between both Advanced Steel and Revit. But let's just go ahead and take a look at what we can do now in Advanced Steel and the sort of things you want to look out for with connections and importing the load cases from Advanced Design to Advanced Steel. So we'll go ahead and open up Advanced Steel here. As you can see, I have a new file open. We'll just go ahead straight to the Export and Import tab, and we'll go ahead and import the model from Revit. So here we're to change it from SMLX to GTCX. So that is the Graitec native file format. And here we're to select the extension AD model to Revit. So just like that, everything is imported. And here we'll see all the steel members with the nodes. Okay, so this is actually an Advanced Steel native elements. This will only appear typically if you, of course, apply them. So here we have those node functionalities in Advanced Steel. However, their true purpose is to retain the forces from linear analysis software like Robot or Advanced Design. Here, if we double click on the node, you can make certain changes. So here you'll see the node support type. You can change that from fixed, hinge, none, or other. And here you can visualize all the forces in strong side, weak side axis, of course. So all the forces, the internal forces at the node. Now, out of the box with Advanced Steel, of course, we do have connection design tools within these connection applications. So here I'm going to go over to the connection vault. We'll just take a look at applying a connection. So here by selecting main member and secondary member, the connection will apply. And here, for those who are not familiar with Advanced Steel and are more Revit users, well, you might notice these dialogues to be similar. The connections that appear in Revit are initially or they are from Advanced Steel, actually. So the dialogues to navigate through and modify your connection parametrically, all those will be the same. You'll always have an image on the right that reflect the cells on the left. So in order to save time in this regard, we'll just go ahead and select one of the connections that are saved from the library. So here it's already defaulting to a saved connection. And we'll just jump over to the design portion of the dialog. Now here, for this particular connection, we only have the EC3 module available. However, I would say about 70% of the connections within the connection vault encompass the AIC module as well. Now, here you'll notice that there aren't any predefined forces. This is something that you would have to type in manually unless you're importing from a linear analysis software. Now, of course, you can adjust the settings, the basic settings in terms of the bolt thread condition, the weld electrocode, and so on. And here, however, if imported from a design solution like Robot or Revit, Advanced Design, you can use the load cases from the node. So now here, of course, this connection isn't exactly the same as in Advanced Design or the connection that was displayed in Advanced Design. And this is just to show that if you verify the connection and it fails, this will act as a way to quality control your work, double check your work, and make sure everything is the same as in Advanced Steel as in Advanced Design. So here we can print out the report based on the internal forces and see what exactly is failing. So here, if you're seeing that the bolt spacing perhaps is failing or something specific with the connection, you can then, of course, go ahead and revise this quite quickly. Now, if ever a connection does fail, you can always change the approval status and then communicate this report back to the engineering department. They can see if it's something due to the internal forces or if there's something specific that you've done wrong as a designer, and then communicate those changes that need to be done. Now, if this was a much larger model, how would you find this connection easily? Of course, if let's say there was 15 different levels and multiple different bays, of course, you'd want to be able to find this connection quickly, and that's why we're changing the approval status here, is to have an additional feature in order to filter the model and facilitate finding this connection. So what we're going to do is go over to the Advanced Tool Palette, and we're going to take a look at the Selection tab, and here we'll find the Search Filter tool. Here, of course, there's many different parameters. You can filter out basically any different variable in your model pertaining to the advanced properties or the individual properties of a member or specific settings to a connection, so on and so forth. Here we're to search on the complete model, and here we're to add new markings so we can see a visual change when searching the element. And here under Objects, we're to go ahead and select the joints. Now here, if you'd like, you can even refine the search. So of course, we're to go into joints and we're to filter out specifically on the approval status. However, we do have many different options here. If you want to find just one specific connection, you can filter out based off of ID, design status, what has been calculated or not. And here we'll talk about these in a bit. So if it's a master connection within a group or not, etc. So here we're to go ahead, select what is rejected. And here, you might have seen that the box turned red. Of course, if you're dealing with a very large model, it could be difficult if you have multiple connections and multiple joint boxes in place and the model is quite cluttered. It could be difficult to see. However, there's additional tools to facilitate the search. So here, if we click on this icon, it'll search for the marked object and point it out to you like so. Let's take a look at the copy tools. So of course, we know that Revit can apply connections as well. So this part of the process, of course, this will improve over time within Revit. However, the connections are relatively new. They were introduced into Revit in 2018, of course, have been improved in 2019. But Advanced Steel is just a little bit easier to copy around the connections at the moment. So we'll take a look at what we can do to facilitate copying these around. Here, there's some dedicated copy tools, joint copy multiple, and here we have two other functions, joint, create joint in a joint group, and create joint in a joint group multiple. So these two first copy tools are just meant to copy over the connection without creating any sort of intelligent link. However, the other two join them together into groups so that if you were to update one connection, it will update all the rest in the group automatically. So here, just to give an example of a simple copy, we'll select our main and secondary member, and it'll copy over the connection. Now, at first, it will not show the joint box, okay? However, it did not just copy the geometry, it really did copy the intelligence of the connection as well. It's just a default that it will not display the joint box. So if we select any of the elements, right-click, we'll still see the advanced joint properties here in the pull-down menu, and we can activate that and see the intelligence box afterwards. So notice here that the approval status is not applied for this particular connection, even though we copied. Well, that's because we did not use the join group function. If we use the join group function, of course, it'll copy all variables within the connection and link them together. So even approval statuses will apply as well. Let's go ahead and delete this connection and reapply it with the joint in a join group function. So now here, if we go into the parameters, we will see that it copied over the approval status as well. So this just gives you an idea, depending on the type of connection or the specific scenario, you might want to just create by template or use the join copy feature, or you might want to join them into groups to facilitate searches or just general modifications. Another example here, if we go ahead and back into the connection vault to have another, let's go ahead and apply the eaves haunch to flange. So I'm going to select my column, my main member, right click, and then secondary member and right click. And now it's applied this connection. Let's go ahead and base it on multiple selections. So create joint in a joint group multiple. Now here I'll go ahead and select all my columns. Oh, let's do that again. And then I'm going to select all the secondary members to quickly apply those connections. Now, if I were to make any sort of change, here I'll make a physical change to the connection this time. So I'll go ahead and change the depth from the rafter towards the bottom. I'll exaggerate the change. Here we'll change it to 400 so it's easy to see the modification, and we see the connection updates quite easily. So these are some of the reasons why you would want to use Advanced Steel over Revit for this specific task of the project, applying the connections and maybe miscellaneous steel and so on. We also have other easy to use tools to view the clash detection as well. So if you find any volume clashes here, actually it's once you click on the clash detection function, it'll bring up this dialog, and you can select, double click to view the volume clash as well. It makes it very easy to just navigate through any, all the clashes and make your changes to find scenarios where you forgot maybe to apply a connection, things of that type. Let's go ahead and open up a model. Here I have a model predefined with all the connections added. Let's go ahead and take a look at some other reasons why you'd want to use Advanced Steel for the fabrication side of things. So here, of course, Advanced Steel encompasses a numbering tool. So, of course, for fabrication drawings, this is critical. You need to apply part marks to all the members involved, as well as all the attached parts. And you'd want to do this prior to extracting the details, of course. So let's open up the numbering dialog and take a look for those of you who are Revit users. Now, here in the numbering dialog, you'll be able to apply part marks, single part marks, and assembly part marks. And here you'll also be able to establish the method of application. So here you can use, there's many different methods. You can use a simple counter method, a fractional based method. We have another method that you can apply with drawing numbers. However, there's many different ways of manipulating this tool and actually having the part mark reference of the item be linked to your page number reference as well. So those things are a little bit more technical. Won't be taking a look at them today. You also have additional options here to adjust the format of your part marking method. So here, if you'd like, you can add the project name, even commodity numbers, your phase numbers. You can add in the model name as well. There's many different options that are available to you. Under the special portion of the dialog, you can exclude elements as well as make modifications to the prefix application and so on. Here, a common need is to exclude the numbers to the bolts, anchors, connectors, or shear studs in this case, concrete objects and timber objects. So here we have all these checked off to exclude those items. And now we'll just go ahead, click OK to apply the part marks. Here we'll see another dialog appear, just indicating that all the part marks were applied. And now we can go ahead and create our fabrication details. So here we'll take a look at the drawing styles and drawing processes. So in this case, if we want to create or extract all the details quickly, we would use a drawing process. Now what this does is take a look at the role of the items in your model. So when I'm referring to role, it's taking a look at this specific model role application. So here we have it set to none as default, utilizes the same role as a beam. However, here, if I click on a column, we'll see that its role is a column. So what this means is the process is going to take a look at what the role of the item is and then utilize a drawing template that is best suited for that type of object and create all the details at the same time. Of course, you can base this on selection of items, or you can just scan your whole entire model. This model is quite small, so we could just go ahead and execute all the drawings at once. So here I'll go ahead and use the assembly A3 multi-width BOM process. Now what that means is it's going to compile as many drawings as it can on one sheet prior to going over to the next available sheet, and it will apply a bill of material as well. How Advanced Steel does this is it reads the frame of your page as a coordinate system. So it scans the area available, it'll compile as much information as it can prior to going over to the next available sheet based off the frame. Once the drawings are completed, here we'll be able to view them in the document manager. If we expand the details category, we'll be able to see the drawings that are up to date, meaning reflecting the model. And if any sort of changes were to occur to the model afterwards, let's say there were some changes done from the design side of things, and we had to synchronize changes from advanced design back to advanced steel, of course, then consequentially that would update these drawings. Perhaps maybe the columns were displaced, or the angle of the rafters has changed, etc. The connections have changed. This would cause for updates to be required to your drawings. Here, however, what the document manager does is it's not just a filing cabinet, it actually acts as a way to manage all your drawings, and will update them or flag the drawings that need updates and update them automatically. So here we have 3 different icons available: force update, update revision, and here we have revision. This will just allocate a revision to your drawing without applying an update. So for cases such as if you're at revision 0 of the project, you can just apply a revision in this fashion. Also, we have tools available to extract the NC files, so DSTV files. It's quite easy to use. Here you could just click on NC, and we'll see all the NC files here under the DSTV file category. We also have other tools to extract the DXF files. So here, if I want to extract the DXFs of all the plates, you can just click on that icon. And see them here. So if I wanted to have all this information within one model, the ideal model for that would be Revit. Revit is typically used as a submittal model. And of course, since we're using this to create our overview drawings in this type of workflow, we are just going to send this model now back to Revit and synchronize all those changes. So here, firstly, I'll go ahead and export the model through the advanced export feature. This will extract an SMLX. And here I'll go ahead and update this AS to Revit version 1. Now, why I'm calling it version 1, if you want to keep track of all the changes made through synchronization, you want to keep a log of this, of course, you can call it version 1, version 2, version 3, version 4, etc. I will go ahead and open up Revit. And here, I just want to show that due to the fact that these are both Autodesk softwares now in terms of synchronization, here we can go to the Advanced Steel extension for Revit and synchronize with this tool. So here we'll have export, import, synchronization. Here we'll have various settings that we can adjust as well. So I'll just go ahead and synchronize the changes. Takes a few seconds for the dialog to appear. Now we'll go ahead and click on Load, AS to Revit version 1. I want all the changes to come into effect, so in status, I'm going to go ahead and check for all of them, and then I will go ahead and apply all actions. In some cases, if it's a custom profile, or an extrusion that exists in Advanced Steel and does not in Revit, you will be required to create the family in Revit, of course. In some odd cases, you might be required to do the process of mapping. However, it is not common with the UK profiles. Everything is pretty much seamless in terms of mapping the profiles. Now we'll see these symbols come in, and what these are showing here are the connections in place from Advanced Steel. All right, so now that that's done, we'll go ahead and take a look. So these symbols, of course, can be changed so we can visualize all objects with a connection, but this is how it will appear as default. And another thing to note, again, I mentioned this at the beginning of the session, but if you want all aspects of your connections to show, be sure to adjust your visibility graphics and make sure all the connection elements are checked here. Now, if I wanted to visualize the connections, here we can change the level of detail of the project. So here we're to change it to fine. Save the project. And then here we'll see the connections in place. So once again, there's many different ways of working with these 3 different products, or many different approaches. It depends on the type of project and, of course, the skill set of the designers. If you're more comfortable with Revit, maybe you'd want to use Revit at the beginning and apply the connections within Revit. If you were more comfortable with Advanced Steel, of course, you can even start the project in Advanced Steel, send the information to Advanced Design, then send the information to Revit. If, let's say, all you need is a rendering, there's many different ways of collaborating with these products. Now, this is what we wanted to show for today. Are there any questions? We can go ahead and start the Q&A session. Okay, so here. We don't see any questions appearing. Give another 2 minutes if anyone has any questions at all, anything at all. Don't hesitate. Can you do a basic model in Advanced Steel and send it into Advanced Design? Yes, of course. Design for the loads. Yeah, absolutely. So with Advanced Steel, here I'll just go ahead and open up the model. The advanced exports will actually give you multiple options. So, or not necessarily multiple options, but the SMLX will be able to be loaded in Advanced Design as well. There's also other formats. So Advanced Design is compliant with the industry standards as well, IFC, CIS2, SDNF. So there's many different ways that you can import a model from Advanced Steel into Advanced Design. And then once, of course, you run the analysis in Advanced Design, you can then synchronize that back to your Advanced Steel model and get the internal forces at the node to facilitate verification of connections. You can do that in both, of course, Advanced Design with the BIM designer. You can do that in Advanced Steel. There's just many options available to you in that regard. Is Advanced Steel working with Sophistic? Not 100% sure. This is something we can look into. I personally am not experienced with this with the software, but of course, you can email us and we can always take a look. All right, so if there are, we got one more question that came in. Does Advanced Design cover cold rolled elements? Yes, it does. Sarah, if you want to elaborate on that, or?
Yes, we can create cold rolled elements, but the transition with Advanced Steel is not that seamless for this type of elements. So for now, we can work with this kind of elements in a limited way, but you can still perform your calculation with cold roll elements inside Advanced Design.
So by it not being that seamless, there can be scenarios where you'd have to map sections from Advanced Design into Advanced Steel and so on. There could be things of this type. However, the transfer is still possible. It just might not be seamless right off the bat. All right, everyone. So if there are any other questions, once again, you can email us. And just to show this slide again for the upcoming webinars, we have a few this week, and a few coming up next week. So I thank you all again for joining the session. Have a great day, everyone.